Assalamu alaikum warahmatullahi wabarakatuh. So I'm going to discuss with you some problems you have sent to me on the Teams. The first one here, a man drives to a town 100 kilometer away at an average speed 60 kilometer per hour. He returns at an average speed 40 kilometer per hour. So he goes to a town, his speed, and the town is 120 kilometer away, and his speed is 60 kilometer per hour. Then he returns back to the same place again so he returns back the same distance, which is 120 kilometer, at an average speed 40 kilometer per hour. What is the average speed for the entire trip? Okay, here I will calculate the time for each one, and I know that the average speed equals the total distance, and the total distance here, he went 120 kilometer forth and another 120 kilometer back, so it's 240 kilometer. This is the total distance, 240 kilometer, divided by the total time. Here there are two times: the time of the first trip when he goes to the town, and the time when he returns back from the town. So I need now to calculate the time of each one. I will say the time equals the distance over the speed. Okay, so for the first time, the distance d1, of course they are the same distance, over the speed v1, so 120 kilometer divided by 60 kilometer per hour, that's half an hour. So this is the first time, half hour. Plus I will do the same to calculate the second time. So the second time, T2 here is the time when he returns back, equals d2 over v2. The distance is the same. He returns the same distance, 120 kilometer, divided by the speed, which is 40. Okay, I think I did something wrong here. 120 over 60, that's 2 hours. It's not half hour. That's 2 hours. Okay, 2 hours. Excuse me. And here over 40 kilometer per hour, so that's 3 hours. So H2, or the time T2, is 3 hours. So I don't need to write H. I don't need to get confused. So the total time here is 5 hours. So the result's average speed is 240 divided by the 5 hours. That's kilometer, and this is an hour. So the result will be around 48 kilometer per hour. Okay? So let's go to another one. A runner A initially 4 kilometers west of a flagpole and is running with constant velocity. I think I solved this one in one of my videos, but let me do it again. It's not a big deal. Okay. So here I have a flagpole, and there are two runners. Runner A is initially 4 kilometers west. So runner A is 4 kilometers west of the flagpole. This is the flag. And is running with a constant velocity 6 kilometers per hour east. So he runs at 6 kilometers per hour toward the flagpole. Runner B is initially 3 kilometers. So he's like 3 kilometers to the east of the flagpole, and is running at constant velocity 5 kilometers west. So he runs at a velocity 5 kilometer per hour west. How far are the runners from the flagpole when they meet? Let's assume this one will run, also the other one will run at the same time, so they will meet at a certain point. I don't know where is this point. It might be at the west of the pole, it might be at the east of the pole, it might be the pole itself. I'm not sure. So let me say it's any point. Okay, so this one runs and this one runs until they meet, they will stop. Okay, so how far are the runners from the flagpole? I need to find the distance from the flagpole to the position where they meet. Okay, what is the common here? When both runs, okay, the first guy A and the second guy B, they will run a distance dA and a distance, let me call it here, dB, and here this one, he will cover a distance dA. If you sum the distance dA plus dB, regardless the position, I don't know where is the position when they will meet, but if you sum the distance, the first guy plus the second guy, okay, it gives you the total distance between them before they move, which is what? Which is 7 kilometers. So the distance in between is 7 kilometers before they start. So this is an equation. Okay. I know the speed of the first one and the speed of the second one. So let me have a relation between the speed and the distance of each one. Okay. So the distance dA equals the speed of the first man, okay, times the time required to reach to the position where we don't know. Let me call this time t. And also for the other one, dB, the distance that he will travel or move, equals to his speed times the time required until he reaches to the same position, which also I don't know. The two times are the same because they will start at the same moment and they will meet each other at the same moment. So the time of the trip of the first person is the same time as the trip of the second person. They start at the same time, they end at the same time. Then let me substitute both equations in the first one. So I will say 6t plus 5t equals the 7 kilometers. So 11t equals 7 kilometers. So t equals what? 7 kilometers, okay, divided by it should be the kilometer per hour, okay, the 11 kilometer per hour. So the result is 7 over 11 hours. 7 over 11, which is 0.636 hours. So let's substitute this time in any of the two equations. Let me substitute it in the first equation, dA. So I will know the distance dA, or in the second equation I will know dB. Multiply the time times 6, so 6t times 6 gives me 3.818 kilometer. Okay, almost we can approximate it to 3.82 kilometer, just up rounding. Okay, dB also 5 times the 0.636. Let me do it. That's also 3.1818. We can approximate it also into 2. Okay, or we can keep it 3.18, that's better, kilometer. So the distance B is 3.18 kilometers. What does it mean? Let me show you. So this person moves a distance 3.18 kilometer, while at the beginning he was at 3 kilometer from the pole. So what is the distance between the position he reaches to and the pole? Of course, 3.18 minus 3, it gives you 0.18 kilometer. So it's the first one. You can get it also from the second guy. The second guy, he moves a distance dA, which is 3.82, while his position, or the distance between him at the beginning and the pole, is 4 kilometer. So we can get D equals the 4 kilometer minus 3.82. It gives you also 18.18 kilometer. So if you use this one or this one, they give you the same result. Let's move to something else. This one also, I think I solved it in one of the videos, so you can watch it there. I don't want to lose your time to solve the same problems in the same video. A speeder passes a parked police car. There is a parked police car. Parked means it does not move. So he passes with it and he moves. And his speed is 30 meters per second. The police car starts from rest. So when the police car so this guy speeding up or moves with high speed, it starts to move. So it will start from rest with V initial equals 0. And a uniform acceleration. Uniform acceleration means constant acceleration. And when you have constant acceleration, you can use the 3 equations of motions we talk about in the lecture. We talked about in the lecture. Okay. The acceleration here equals 2.44 meter per second square. How much time passes before the speeder is overtaken by the car police? So let's say this is the lane of the speeder. He starts from here and he moves with the speed which is 30. Let me do it here. 30 meter per second. Okay. When he becomes side by side with the police starts to move with this acceleration. So let's assume the police will catch him at this position. When he reaches here, let's say the police will be able to be side by side with him again. Okay. We need to calculate the time until his car is overtaken by the police car. Okay. Here I have 2 problems. Both of them have the same time because they start, I will start counting the time starting from here and I will end it when he is caught by the police. So this is the time. Also, what about the distance? It will be the same distance. The distance between this point and this point will be the same. So the distance and the time are the same. But the difference in what? The speeder, he moves with a constant speed. While the police car, it has an acceleration. So its velocity or its speed increases. Okay? Okay, so let's make an equation for the speeder. Let me call the speeder B and the police car A. For the speeder, we can relate the distance to the time to the speed. I will say D equals V T. That's for the speeder B. And we said the distance is the same, so I will keep it D. So the distance equals 30 times T. This is the first equation for the speeder. For the police car, I need to relate the distance to the time to the acceleration. So which equation has the distance and the time and this one? The last equation, which is delta S equals VI times T plus half times A times T square. We can say delta S here is the distance because it's moving in one direction. V initial, it starts from 0 speed. It was at rest. So this is also 0. So the distance equals half at square. So I can substitute it, half times a, which is 2.44, times t square. So this is the second equation. Let me call it equation 1 and equation 2. How to solve those two equations together? I can divide 2 over 1. Divide 2 over 1. So d over d gives you 1. And half times 2.44 t square divided by 30t. We can remove this t with the square. So I can remove this t with the square. So I can find the time t equals 30 times 2 divided by 2.44. Let me find it. That's 60 divided by 2.44. The time is, just a second. I know it will be 24.6, but I need to calculate it myself with the calculator, so I want to show you that this is right. So 24.59 seconds. So which is the first answer. Let's go to another one. A ballast bag is dropped from a balloon that's 200 meters above the ground. So there is a balloon that is 200 meters above the ground, and it raising at 10 meters per second. So its speed is upward because it's raising and equals 10 meters per second. This balloon drops a bag. So somebody in the balloon or whatever the technique, it will leave a bag. When an object leaves another object, so it takes the initial speed of the other object. So the bag will take the initial speed of the balloon. So the initial speed of the balloon was 10. So the initial speed of the bag also is 10. So what will happen? The bag will move up, but because of the gravity, it will decelerate. So its speed decreases until it reaches the maximum height here. Then what will happen is it will fall down until it will reach the ground. Okay, this is the scenario of the motion. So here I need the maximum height reached by the bag above the ground. So the maximum height here coming from this point. I can start by calculating this height. Let me call it h, and then add 200 meters to the h. It will give me the total height. How can I do that? I have the initial speed vi, which is 10. And what is the speed at the maximum height here? 0. Okay. I need to calculate the height. I have initial speed, I have final speed, and I know the gravity. Gravity is 9.8. So which equation can I use? I can use the third equation, v square. Excuse me. V square equals v, or v final square is equal v initial square plus 2a delta s. Of course, delta s will be the height h. Okay. And a is the gravity. So the final here is 0. And the initial is 10, but it's squared. So it's 100. Plus 2gh. 2 times 9.8 times h. And here, because the object moves up, I know that what you do is you put the gravity negative. But actually, to be honest, the gravity, if you are working with vectors, the gravity is always downward. If you are using velocity vectors and gravity acceleration vectors, the gravity must be negative in all cases, but I know you have like compromising this issue. So if the object moves up, you put it negative. If the object moves down, you put it positive. And that's fine for the simple problems. But for the complex problems, it's better to use vectors. Anyway, so h equals 100 divided by 2 times 9.8. So 100 over 2 over 9.8, that's 5.1 meter. So the total height to the ground is what? Total height equals the 5.1 meter plus the 200 meter, this 200 meters, so it's 205.1 meter, which is almost 205. Okay? A ball is thrown vertically upward at 19.6 meter per second for its complete trip up and back down to the starting position. So you throw something, it goes up, and then it comes back to the same position. Its initial speed is 19.6 meter per second. And by the way, when it returns back, its speed also is the same, but in the opposite direction. I think you know that. And at the top point, its speed is 0. The time taken to go upward equals the time taken to go downward. Okay? So the two trips going up and down, they are almost the same. It needs the average speed. The average speed. How to get the average speed here? I will calculate average speed equals total distance, total, so the two trips, divided by total time. If it goes distance d1 and returns back distance d2, they are the same. So the total distance is double the distance, but also the total time is double the time, because it takes a certain time upward and the same time to go downward. So it's like you multiply the numerator by 2 and you also multiply the denominator by 2. So it doesn't matter actually. It doesn't matter. You can take only half of the trip, okay, and divide it over its time. It will give you the same answer. So I will call it d1 over t1. So we need to get the distance and the time. From the first equation, v final equals v initial plus at. I know v final, like let's say from A to B. V final is 0, V initial is 19.6, and of course it goes up, so the same like what we said before, minus 9.8 GT, so the time here is 19.6 divided by 9.8. So that gives us 2 seconds. 2 seconds. We need to get the distance, so we can say delta S equals VIT, or we can use the second or the third equation. It doesn't matter actually. Any one of them will give you the same answer. Plus half AT square. Okay, I think if we use the other one, might be better. V final square equals V initial square plus 2G delta S, and delta S here is the distance D. V final is 0 equals V initial, which is 19.6 square minus 2 times 9.8 times D. So the distance is 19.6 square divided by 2 times 9.8. Let me do it. 19.6 so it gives you also 19 point. Actually, the denominator here is 19.6, so we can cancel it out with the square. So it's 19.6. So we need to divide d over t. D over t is 19.6 divided by 2 seconds. It gives us 9.8 meter per second. So this is the average speed. Okay, this is the average speed of the object. If you take the whole distance, if you do that for the whole distance, you need to say that the distance is 2 times d, but also the time will be 2 times t, so the result also at the end will be the same. Okay, guys? Okay, thank you so much. Assalamu alaikum wa rahmatullah.